When you watch Hollywood war movies or play modern video games, there is a very specific monster that always lurks in the shadows of the European theater. You know the one I am talking about. The heavy, menacing silhouette of the Tiger tank or the sleek, sloped armor of the Panther. Pop culture has convinced generations of Americans that the German armored forces were exclusively composed of these massive, over-engineered steel beasts that could wipe out entire platoons of Sherman tanks before breakfast. But wars are not won by hangar queens that break their own transmissions every 50 miles. Wars are won by the workhorses. For the United States, that workhorse was the M4 Sherman, a marvel of mass production and reliability. For the Soviet Union, it was the crude but effective T-34. And for the German Wehrmacht, the true backbone of their armored divisions, the only German tank to remain in continuous production throughout the entirety of World War II, was the Panzerkampfwagen IV. Today, we are stripping away the propaganda and the myths to look at the real German tank legend. Before we dig into the armor, the firepower, and the tactical doctrines that define this machine, make sure you hit that subscribe button, ring the notification bell, and drop a comment below telling us which World War II tank you think was the most historically significant. Your engagement keeps this channel on the front line of military history analysis. To understand the Panzer IV, we have to rewind the clock to a time long before the Blitzkrieg, back to the ashes of the First World War. In 1919, the Treaty of Versailles effectively castrated the German military. The Reichswehr was limited to 100,000 men, and they were strictly forbidden from possessing or developing tanks, heavy artillery, or military aircraft. But military minds rarely accept defeat on a piece of paper. Just as the United States Army in the 1920s had to creatively bypass the National Defense Act, which restricted tank development to the infantry branch, the Germans found their own loopholes. They went underground, and ironically enough, they went east. In the late 1920s, the German military established a secret tank testing facility in Kazan, deep inside the Soviet Union, known as the Kama Tank School. Here, far from the prying eyes of British and French inspectors, German engineers and tacticians began testing early prototypes under the guise of agricultural tractors. This is where the seeds of modern armored warfare were planted. A young visionary named Heinz Guderian was formulating a radical new doctrine. While the French and the British still viewed tanks as slow, heavily armored battering rams designed to escort infantry across muddy trenches, Guderian envisioned independent, highly mobile armored formations that could strike deep into enemy territory, severing supply lines and paralyzing command structures. But to execute this doctrine, Guderian needed specific tools. He did not just want a generic tank, he wanted a specialized dual tank system. The primary combatant was to be a medium tank armed with a high-velocity armor-piercing gun to destroy enemy tanks, which would eventually become the Panzer III. But Guderian knew that enemy tanks were not the only threat on the battlefield. What happens when your fast-moving armored spearhead runs into a fortified machine gun nest, an entrenched anti-tank gun, or a concrete pillbox? You do not use an armor-piercing kinetic penetrator against a dirt bunker. You need high explosives. Therefore, Guderian demanded a heavier support tank, armed with a large-caliber gun capable of firing devastating high-explosive shells to clear the way for the Panzer IIIs and the infantry. In the bureaucratic labyrinth of the German Army Weapons Agency, this project was deliberately mislabeled as the Begleitwagen, or escort vehicle, to hide its true nature. If you think designing a tank by committee in the Pentagon is a nightmare, you should try navigating the German procurement system in 1934. Contracts were handed out to Rheinmetall, Krupp, and MAN to design this new support vehicle. Krupp, a massive industrial conglomerate with a long history of forging artillery, ultimately won the contract. By 1936, the first production model, the Panzer VI Ausführung A, rolled off the assembly line at the Krupp-Grüßenwerke plant in Magdeburg. Let us look at the technical specifications of this early variant, because it is crucial to understand how far this tank eventually evolved. The Panzer IV Aus FA weighed around 18 tons, which is incredibly light by later standards, roughly the weight of a modern M2 Bradley infantry fighting vehicle without its reactive armor. It was powered by a Maybach HL108TR 12-cylinder gasoline engine, producing 250 horsepower. This gave the tank a top speed of about 19 miles per hour on roads. The armor, however, was shockingly thin. At its thickest point on the front hull, the armor was only 14.5 millimeters thick. To put that into perspective, 14.5 millimeters of non-sloped steel is barely enough to stop a 50 caliber armor-piercing round fired from an M2 Browning machine gun, and it would be absolutely shredded by any dedicated anti-tank weapon of the era. But remember the Doctrine. This tank was not designed to slug it out in a heavy armor duel. It was designed to sit back slightly and lob high explosives at infantry positions. The main armament was the 75mm Kampfaugenkano 37L24. In military nomenclature, L-24 means the length of the barrel is 24 times the diameter of the bore. This was a very short, stubby barrel. It fired a low-velocity shell with a muzzle velocity of just over 1,260 feet per second. While it was highly effective at delivering a heavy explosive payload onto a soft target, its anti-armor capabilities were practically non-existent. One of the most interesting engineering choices on the Panzer IV was its suspension system. While the Panzer I utilized a highly advanced but complex and expensive torsion bar suspension, the Panzer IV relied on a much simpler system of quarter-elliptic leaf springs. It featured 8 small road wheels on each side, paired up into 4 bogies. Why use leaf springs on your premier support tank? Because the German High Command knew that a tank breaking down in the field is just as useless as a tank destroyed by enemy fire. Leaf springs were cheaper to manufacture, required less specialized machining, and most importantly, if a mine blew off a road wheel, a field maintenance crew could unbolt the damaged bogie and replace it relatively quickly. Compare that to a torsioned bar system, where a broken bar often meant dragging the tank back to a heavy repair depot and practically disassembling the lower hull to extract the shattered steel rod. Logistics and maintenance dictate the pace of war, a lesson the Germans understood early on, even if they forgot it later when they started building 70-ton King Tigers. But the true revolutionary feature of the Panzer V was not its gun or its tracks, it was the interior layout. The Germans pioneered the 5-man crew concept, which became the gold standard for tank design and is still largely reflected in modern tanks that do not use autoloaders. You had a commander, a gunner, and a loader situated in the turret, while the driver and the radio operator sat in the front hull. This division of labor was a massive tactical advantage. Look at the French tanks of the same period, like the heavily armored Char B1 bis. The French tank commander sat alone in a one-man turret. He had to spot targets, load the gun, aim the gun, fire the gun, and direct the driver all at the same time. He was basically juggling flaming chainsaws while trying to fight a war. In the Panzer IV, the commander had one job, and that was to command. He stood in a dedicated cupola with 360-degree vision blocks, maintaining total situational awareness. Furthermore, every single Panzer II was equipped with a two-way radio, and the crew communicated via an internal intercom system. This allowed German armored platoons to coordinate their movements with fluid precision, acting as a unified fist rather than a collection of blind, deaf individuals. Do you really think a superior gun matters if you do not even know the enemy is flanking you because your commander is too busy struggling to load a heavy shell? Situational awareness kills the enemy faster than armor thickness saves you. However, as Europe marched toward the abyss in September 1939, the German industrial reality did not match their grand tactical ambitions. We Americans often think of World War II production in terms of the Detroit Arsenal tank plant, where massive assembly lines churned out Shermans by the tens of thousands using automotive mass production techniques. The German defense industry in the late 1930s was nothing like that. It was essentially a collection of artisanal workshops. Tanks were practically hand-built by highly skilled craftsmen. Parts were machined to exacting tolerances, which made them beautiful pieces of engineering, but incredibly slow to produce. When Germany invaded Poland, they had a total of roughly 2,900 tanks. But here is the shocking truth. The vast majority of those were Panzer Is and Panzer IIs, which were essentially lightly armored training vehicles armed with machine guns or 20mm cannons. The number of Panzer IVs available for the invasion of Poland was a mere 211. They were deployed sparingly, usually serving as the heavy company within a panzer battalion, providing vital fire support when the lighter tanks ran into fortified Polish positions. The campaign in Poland validated Guderian's concept of mobile warfare, but it also exposed the glaring vulnerabilities of the early Panzer IVs. The 14. 5mm armor was easily penetrated by Polish 37mm Bofors anti-tank guns and even by heavy anti-tank rifles. This led to immediate field modifications and the push for upgraded variants. By the time the Germans turned their eyes toward France in May 1940, the Panzer IV had evolved into the AUF-C and AUF-D models. The frontal armor was bolted up to 30mm, which offered better protection, but it was still woefully inadequate against the heavy guns of the Allies. Let us look at the force comparison during the Battle of France. On paper, the French and British had more tanks, better armored tanks, and heavily armed tanks. The British Matilda II had up to 78mm of frontal armor, a veritable moving bunker that the Panzer IV's short 75mm gun could not even scratch, let alone penetrate. The French Char B1 bis had 60mm of armor and mounted both a 47mm anti-tank gun in the turret and a 75mm howitzer in the hull. If this were a game of top trumps, the Allies would have won easily. So how did the German panzer divisions, equipped with a handful of Panzer CYIs and Panzer IV, completely dismantle the Allied armies in just 6 weeks? It all came down to doctrine, speed, and communication. The French dispersed their heavy tanks in small packets, attaching them to infantry divisions as localized support. The Germans concentrated their armor into massive, independent panzer divisions. When a German spearhead, like the 1st Panzer Division under Major General Friedrich Kirchner, encountered a heavily defended French position, they did not stop to fight a war of attrition. The Panzer IVs would lay down a barrage of high explosives and smoke shells to blind and suppress the enemy, while the lighter, faster tanks bypassed the strong point entirely, racing deep into the French rear to destroy supply depots and command posts. How do you fight an enemy that refuses to engage your heavy armor, but instead cuts off your fuel, your ammunition, and your communications? The French heavy tanks simply ran out of gas and were abandoned by their crews. The Panzer IV proved that operational mobility and combined arms tactics could overcome severe technical disadvantages in armor and anti-tank firepower. But this tactical superiority bred a dangerous sense of arrogance within the German high command. They believed their radio-equipped, fast-moving panzer divisions could outmaneuver any enemy on Earth. They believed the short-barreled support gun of the Panzer IV was sufficient, because they assumed they would always dictate the terms of engagement. They were about to learn a very bloody lesson. Because while the fields of France were perfectly suited for high-speed maneuvers against a rigid, slow-reacting enemy, a storm was gathering in the east. Adolf Hitler was preparing to launch Operation Barbarossa, the largest military invasion in human history, plunging his armored spearheads into the vast, unforgiving steppes of the Soviet Union. And waiting for them in the mud and the snow was a new generation of Soviet armor, machines with heavily sloped steel and massive guns that would render the early Panzer IV completely obsolete overnight, forcing a desperate, frantic evolution that would change the course of tank design forever. On the morning of June 22, 1941, over 3 million German soldiers, supported by 3,350 tanks, surged across the Soviet border in Operation Barbarossa. The German High Command expected a swift, decisive victory, a repetition of the mechanized blitz that had shattered France. The Panzer IV, still armed with its short-barreled 75mm L-24 gun, was tasked with its usual role of providing high-explosive fire support for the infantry and the lighter Panzer IIs. For the first few weeks, the Doctrine worked flawlessly as German armored spearheads sliced through disorganized Soviet formations, encircling hundreds of thousands of Red Army soldiers. But as the panzers pushed deeper into the vast expanses of Ukraine and Belarus, they encountered a terrifying new reality that shattered their illusion of armored supremacy. Emerging from the tree lines and the dust of the steppes were the Soviet T-34 medium tank and the massive KV-1 heavy tank. The German tank crews were suddenly facing machines equipped with heavily sloped armor, a design feature that artificially increased the thickness and effectiveness of the steel plates. When a German gunner in a Panzer IV lined up a T-34 in his Zeiss optics and fired his standard armor-piercing shell, the Panzergranate 39, the result was absolute dismay. The low-velocity shell, traveling at a sluggish 1,260 feet per second, would strike the 60-degree sloped glacis of the T-34 and simply shatter or ricochet harmlessly into the sky. Against the 45-ton KV-1, the situation was even more desperate. German after-action reports detailed horrific engagements where a single KV-1 absorbed dozens of direct hits from 37mm and short 75mm guns without suffering a single penetration, methodically destroying the German tanks in return. How do you fight a war of annihilation when your primary weapon is suddenly as effective as a pea shooter against a steel vault? You adapt immediately or you die. This technological shockwave was triggered an absolute panic within the German Army Weapons Agency. The Panzer III, which was supposed to be the dedicated tank killer, could not fit a gun large enough to defeat the new Soviet armor due to the restrictive diameter of its turret ring. The only chassis in the German inventory capable of mounting a larger, heavier, high-velocity gun was the Workhorse, the Panzer IV. Overnight, the intended role of the Panzer V was completely inverted. It was no longer a support tank designed to lob high explosives at bunkers. It had to become Germany's primary main battle tank, the dedicated tank killer of the Wehrmacht. This desperate pivot mirrors the exact same crisis the United States Army faced in Normandy in 1944. When American Sherman crews realized their standard 75mm guns were bouncing off the frontal armor of German Panther tanks, the U.S. Ordnance Department had to frantically rush the long-barreled 76mm gun and high-velocity, armor-piercing ammunition to the front lines. The Germans simply experienced this brutal wake-up call 3 years earlier. The solution engineered by Krupp and Rheinmetall was the Kampfwagen Kanon 40L-43, a long-barreled 75mm gun that would transform the Panzer IV from a close support brawler into a lethal long-range sniper. This new weapon was fitted into the Panzer IV Ausführung F2, which began reaching the Eastern Front and North Africa in the spring of 1942. The ballistic upgrade was staggering. The barrel length was nearly doubled. The muzzle velocity skyrocketed to over 2,400 feet per second. With standard armor-piercing ammunition, the new gun could penetrate 89mm of sloped armor at a range of 1,000 yards. For the first time since Barbarossa began, German tank crews could reliably destroy a T-34 at combat ranges before the Soviet tank could close the distance. But strapping a massive, high-velocity cannon into a tank designed in the mid-1930s came with severe engineering consequences. The recoil of the new L-43 gun was incredibly violent, threatening to rip the turret ring right off of the hull. To mitigate this, German engineers fitted a distinctive, bulbous single-baffle muzzle brake to the end of the barrel, later upgrading it to a double-baffle design. This device redirected the explosive propellant gases sideways and backward as the shell left the barrel, significantly reducing the recoil impulse transferred into the tank's delicate mechanical systems. However, the sheer weight of the longer barrel made the turret heavily nose-heavy. To balance it, a heavy counterweight had to be welded to the rear of the turret, increasing the overall weight of the vehicle. As the Panzer IV evolved into the OSFG and eventually the definitive OSH model, the armor protection was also drastically increased to survive the brutal realities of the Eastern Front. The frontal hull armor, which started at a mere 14.5mm in 1936, was bolted and eventually welded up to a massive 80mm of flat steel. The weight of the Panzer IV ballooned from 18 tons to over 25 tons. This is where the limitations of the original design began to severely hamper its operational mobility. The simple leaf spring suspension, which was praised for its ease of maintenance, groaned under the massive increase in weight. The tank became sluggish, its top speed dropping, and the strain on the Maybach engine and the transmission led to a spike in mechanical breakdowns. More importantly, the ground pressure increased dramatically. The tracks of the Panzer IV were only 15.7 inches wide. When the autumn rains hit the Russian steppes, creating the infamous Rasputitsa, or mud season, The heavy, narrow-tracked Panzer IVs sank up to their bellies in the freezing sludge. In stark contrast, the Soviet T-34 utilized massive 19-inch wide tracks, distributing its weight far more efficiently and allowing it to glide over the mud and snow that paralyzed the German logistical and armored columns. Despite these mobility issues, the lethality of the upgun Panzer IV could not be denied. When Erwin Rommel's Afrika Korps received a handful of the new Ausf F2 models in the Western Desert, the British 8th Army was horrified. The British designated this new threat the Mark IV Special. Americans supplied M3 Stuart and M3 Grant tanks, which had previously held their own against German armor, were suddenly being picked off at ranges exceeding 1,500 yards, long before their own 37 or 75 mm guns could effectively return fire. But the ultimate crucible for the Panzer IV, the battle that would define its legacy and test its crew to the absolute breaking point, occurred in the blistering heat of July 1943. Operation Citadel, the Battle of Kursk, remains the largest armored engagement in human history. The German High Command planned a massive double envelopment to pinch off a Soviet salient, committing over 3,000 tanks to the offensive. By this point in the war, the mythical Tiger and Panther tanks had made their debut, but they were available only in limited numbers and suffered from catastrophic mechanical unreliability. The Panther tanks at Kursk literally caught fire on the way to the assembly areas due to poorly designed fuel systems. Therefore, the tip of the German spear, the absolute workhorse of the armored divisions, was once again the Panzer IV, specifically the heavily up-armored Ausf-G and Ausf-H variants. These late-model Panzer IVs featured a distinct visual modification known as Schürzen, or side skirts. These were 5 mm thick steel plates hung on rails along the sides of the hull and wrapped around the turret. Pop culture often mistakenly claims these skirts were designed to defeat American bazookas or shape-charge weapons. This is historically false. The Schürzen were specifically developed to counter the Soviet 14.5 mm PTRD anti-tank rifles. Soviet infantry used these long rifles to snipe the thin 30 mm side armor of the Panzer IV from concealed positions in the rubble or tall grass. When a high-velocity tungsten core bullet struck the 5 mm skirt, it would tumble, shatter, or lose its ballistic trajectory before it could strike the main armor of the tank, saving the crew inside. Let us reconstruct the brutal reality of armored combat at Kursk, focusing the southern pincer commanded by Field Marshal Erich von Manstein. The spearhead of this assault was the IISS Panzer Corps, commanded by General Paul Hauser, comprising elite divisions like the Leibstandarte, Das Reich, and Totenkopf. On the morning of July 12, 1943, the climax of the battle unfolded near the small village of Prokhorovka. At 0630 hours, the sun rose over the rolling steppes, baking the earth as the temperature rapidly climbed toward 90 degrees Fahrenheit. The German Panzer IVs were arrayed in a defensive posture on a series of low ridges, including Hill 252. 2. Suddenly, the horizon darkened with dust. General Pavel Rotmistrov of the Soviet 5th Guards Tank Army had ordered a massive point-blank counterattack. Over 800 Soviet tanks, primarily T-34s and light T-70s, surged forward across the open ground, charging directly at the German lines at maximum speed. The Soviet tactic was simple and brutal. They knew the German long-barreled guns, and superior optics gave them a massive advantage at long range. To negate this, the Red Army tankers were ordered to close the distance as rapidly as possible, engaging in a point-blank brawl where the superior maneuverability of the T-34 could overwhelm the slower, heavier Panzer IVs. Can superior optics, precise engineering, and rigid crew discipline withstand a tidal wave of steel coming at 30 miles per hour? Inside the sweltering fighting compartment of a Panzer IV, the temperature easily exceeded 100 degrees Fahrenheit. The commander stood in his cupola, his eyes pressed to his binoculars, calling out targets through the intercom. The gunner peered through his Zeiss TZF-5F telescopic sight, a masterpiece of optical engineering that provided incredible clarity and range-finding capability. At 1,500 yards, the gunners opened fire. The crack of the 75 mm WK-40 echoed across the steppe. Inside the turret, the violence of the recoil was terrifying. The massive breech block slid back, ejecting a smoking, glowing brass casing onto the floor. The fighting compartment instantly filled with the acrid, choking stench of cordite burning the eyes and lungs of the crew. The ventilation fan on the turret roof was completely inadequate to clear the toxic smoke. The loader, sweating profusely in the cramped space, grabbed a 15-pound fixed ammunition cartridge from the storage bins beneath his feet. With practiced muscle memory, he slammed the shell into the breech. The breech block snapped shut automatically. He yelled, "Up!" over the intercom. The gunner made a micro-adjustment on his hand wheels, leading the speeding T-34, and squeezed the firing pedal. Another deafening roar. Another armor-piercing round crossed the steppe at 2,400 feet per second, striking the front slope of a T-34 and detonating its ammunition rack in a catastrophic fireball. The German crews were firing around every 6 to 8 seconds, laying down a devastating wall of kinetic energy. But the Soviet wave was too massive. Within minutes, the T-34s had closed to within 500 yards. The battle degenerated into a chaotic, swirling melee. This was a point-blank slaughter, highly reminiscent of the savage nighttime naval battles at Guadalcanal, where American and Japanese warships engaged at pistol-shot range in the dark, blasting each other to pieces. Except this was happening on a dusty plain in the blinding summer heat, with steel grinding against steel, tanks ramming each other, and crews firing at targets just yards away. In the dust and smoke, visibility dropped to near zero. The Panzer IV's commanders had to expose themselves, opening their hatches to see the battlefield, making them prime targets for Soviet shrapnel and machine fire. The manual turret traverse of the Panzer IV, which required the gunner to furiously crank a hand wheel to turn the heavy turret, was painfully slow compared to the fast-moving Soviet armor. If a T-34 flanked a Panzer IV, the German crew often had to pivot the entire tank using its tracks to bring the main gun to bear, a maneuver that put immense strain on the already overburdened transmission. By the end of the day on July 12th, the fields around Prokhorovka were a graveyard of burning steel. The Soviet 5th Guards Tank Army had suffered catastrophic losses, losing over 50% of its committed armor. The German Panzer IV crews had demonstrated horrific efficiency, utilizing their superior guns and optics to exact a massive toll on the charging Red Army. But tactically winning a single engagement does not win a war of attrition. The German losses, while numerically lower, were strategically irreplaceable. The Wehrmacht had exhausted its armored reserves, burned through its meticulously accumulated fuel stockpiles, and lost thousands of highly trained veteran tank crews that the artisanal German training pipeline could never replace. Operation Citadel was cancelled. The initiative on the Eastern Front permanently shifted to the Soviet Union. The mighty panzer divisions, built for rapid offensive encirclements, were now forced into a grinding, desperate war of defensive retreat. The Panzer IV, designed to spearhead the Blitzkrieg, was about to become a mobile pillbox, fighting a delaying action across thousands of miles of scorched earth. And as the battered German armored columns began their long, bloody withdrawal across the Dnieper River, an even more terrifying strategic nightmare was unfolding in the West, where a massive Allied armada was preparing to unleash an unstoppable tidal wave of American industrial might directly onto the heavily fortified shores of Fortress Europe. When the ramps of the Higgins boats dropped on Omaha and Utah beaches on the morning of June 6, 1944, the strategic calculus of the Second World War permanently shifted. The German Wehrmacht was now caught in the ultimate strategic nightmare, a massive two-front war of attrition against the combined industrial might of the United States, the British Empire, and the Soviet Union. In the lush, claustrophobic hedgerow country of Normandy, known as the Bocage, the Panzer IV was once again called upon to hold the line. By this stage of the war, the German armored forces in the West were a shadow of their former glory, heavily reliant on the Panzerlehr Division and the 12th SS Panzer Division Hitlerjugend to throw the Allies back into the sea. But the tactical environment of Normandy was fundamentally different from the wide-open steppes of Russia or the rolling deserts of North Africa. The Bocage consisted of massive, centuries-old earthen embankments covered in dense vegetation, turning every single agricultural field into a heavily fortified green fortress. In this incredibly dense terrain, the long-range superiority of the German 75mm gun, was completely negated. Engagement ranges plummeted from 1,500 yards down to a terrifyingly intimate 50 or 100 yards. At these point-blank ranges, the American M4 Sherman, with its fast, power-traversed turret and gyroscopically stabilized gun, possessed a massive tactical advantage. An American gunner could often spot, traverse, and fire his 75mm weapon before the German crew could even orient their vehicle toward the threat. Furthermore, the German defense industry was beginning to crack under the relentless pressure of the Allied strategic bombing campaign. This economic strangulation birthed the final and most desperate production model of the Panzer IV, the Ausführung J. If you want to understand the collapse of the Third Reich's economy, you do not need to look at a spreadsheet. You just need to look at the engineering regressions of the Panzer IV Ausf-J. To save critical raw materials and simplify production, the German Weapons Agency ordered the removal of the electric turret drive. Think about the tactical implications of that decision for a moment. In the middle of a life-or-death armor duel, the German gunner was now forced to manually hand-crank the massive, heavily armored turret, fighting against the unbalanced weight of the long-barreled gun. If a tank was parked on a slight incline, manually rotating that turret uphill required exhausting physical exertion, taking agonizing seconds that often meant the difference between life and a fiery death. They also replaced the solid steel side skirts with wire mesh screens, known as Thomasschürzen, to save on steel plate. The armor quality itself was severely degrading. Because the German war machine was starved of critical alloying elements like molybdenum and nickel, the steel used in late-war Panzer IVs became incredibly brittle. When an American 75mm solid shot struck this brittle armor, even if it failed to penetrate the tank, the sheer kinetic shockwave would cause the interface of the armor plate to crack and shatter. This phenomenon, known as spalling, sent razor-sharp flakes of steel flying around the interior of the fighting compartment at supersonic speeds, blinding, maiming, or killing the crew without ever actually piercing the hull. How do you maintain crew morale when a non-penetrating hit is just as lethal as a clean punch through the armor? You do not, you simply fight on pure fatalistic desperation. But the greatest threat to the Panzer IV in Normandy did not come from American tanks, it came from the sky. The Allies possessed total uncontested air supremacy. Swarms of American Republic P-47 Thunderbolts and British Hawker Typhoons prowled the skies above the French countryside. A P-47 Thunderbolt was a massive, rugged fighter bomber that could carry a payload of up to 2,500 pounds of high explosives, including 500-pound bombs and 5-inch high-velocity aircraft rockets. If a German panzer column attempted to move during daylight hours, they were mercilessly hunted down and annihilated from above. General Fritz Bayerlein, commander of the elite Panzerlehr division, reported that his armored columns were practically paralyzed, forced to hide in thick woods during the day and conduct all logistical movements in pitch-black darkness. This brings us to a profound strategic comparison deeply rooted in American military history. The situation the German panzer divisions faced in the summer of 1944 is strikingly similar to the plight of General Robert E. Lee's Army of Northern Virginia during the Overland Campaign of 1864. Lee possessed superior tactical acumen, and his veteran troops routinely inflicted horrific casualties on Ulysses S. Grant's Union Army in battles like the Wilderness and Cold Harbor. But Grant possessed an insurmountable logistical and industrial advantage, backed by a sprawling railroad network and the endless manufacturing base of the North. Lee could win individual firefights, but he was strategically bleeding to death, unable to replace his lost men, horses, or artillery. The Germans in Normandy were the Confederates of 1864. A Panzer IV crew might brilliantly ambush and destroy 3 American Shermans, but the next morning, the Detroit arsenal would deliver 5 brand-new Shermans to the front line, while the destroyed Panzer IV would never be replaced. The Allied logistical apparatus was a masterpiece of modern warfare. Consider the sheer scale of the American supply chain, a concept culminating decades later in the logistical miracle of Operation Desert Storm, where General Norman Schwarzkopf moved entire armored corps and massive supply dumps hundreds of miles across featureless desert in a matter of weeks. In World War II, the United States built over 2,700 Liberty ships to create a continuous, unbreakable steel bridge of supplies across the Atlantic Ocean. In stark contrast, the German logistical network in 1944 was a shattered, burning ruin. The French rail network had been systematically dismantled by Allied heavy bombers. German supply trucks, running on synthetic fuel derived from coal because the Romanian oil fields at Ploiești were heavily bombed, were routinely destroyed by roving Allied fighter planes. A tank without fuel is not a weapon of war, it is a 25-ton steel coffin waiting to be bypassed or blown up. Furthermore, the Allies possessed a devastating, unseen weapon that completely stripped the German armored forces of their operational surprise: the intelligence war. At Bletchley Park in England, Allied codebreakers had cracked the German and Enigma machine ciphers, producing highly classified intelligence known as Ultra. The Allied High Command often read the orders of the German panzer divisions before the German field commanders even received them. This is the mid-20th century equivalent of the Battle of Midway in 1942, where American codebreakers under Joseph Rochefort cracked the Japanese JN-25 naval code. That intelligence allowed Admiral Chester Nimitz to position his aircraft carriers in the exact right spot to ambush the Japanese fleet, turning the tide of the Pacific War in a single morning. In Europe, ultra-intelligence allowed the Allies to pinpoint the exact assembly areas of the Panzer reserves, directing massive artillery barrages and heavy bomber strikes to annihilate the German tanks before they could even reach the front line. Despite these overwhelming disadvantages, Adolf Hitler ordered one final, suicidal roll of the dice in December 1944. Operation Wacht am Rhein, known to Americans as the Battle of the Bulge. The plan was to punch a hole through the thinly defended Ardennes forest, cross the Meuse River, and capture the vital port of Antwerp, splitting the British and American armies. While Hollywood movies focus heavily on the fearsome King Tigers of Kampfgruppe Pipper during this offensive, the harsh mathematical reality is that the bulk of the German armored thrust was carried out by the aging, battered Panzer IVs. The offensive was launched in the dead of winter, under the cover of heavy overcast skies that grounded the dreaded Allied fighter bombers. For a few terrifying days, the Panzer IVs pushed deep into American lines, utilizing the element of surprise and the brutal freezing weather to overrun isolated infantry positions. But wars are dictated by logistics, and the German logistical plan for the Ardennes offensive was fundamentally delusional. The 6th Panzer Army did not have enough fuel to reach Antwerp. The German High Command literally planned the offensive on the assumption that their armored spearheads would capture American fuel dumps along the way to keep their tanks running. Is relying on your enemy to supply your mechanized army a stroke of tactical genius or the ultimate admission of strategic bankruptcy? When the stubborn American defense at Bastogne and St. Vith delayed the German timetable, the Panzer IV simply ran out of gas. They were abandoned on the narrow, snow-choked forest roads, left behind by their freezing crews to reach or blown up by the advancing Americans when the skies finally cleared and the P-47s returned to finish the job. As the war ground to its inevitable, bloody conclusion in the spring of 1945, the Panzer IV fought in the rubble-strewn streets of Berlin. By this point, it was no longer a mobile instrument of Blitzkrieg. It was a static pillbox, hiding in the ruins, firing its final 75mm shells at swarms of Soviet IS-2 heavy tanks and T-34 85s. When the guns finally fell silent in May 1945, over 8,500 Panzer IVs had been produced. It was the only German tank to remain in continuous production from the very first day of the war to the very last. It fought in the freezing mud of Russia, the blistering sands of North Africa, the hedgerows of France, and the mountains of Italy. The Tiger tank was a terrifying propaganda tool that consumed vast amounts of resources for minimal strategic gain. The Panther was a brilliant but deeply flawed design that arrived too late and suffered from catastrophic mechanical failures. But the Panzer IV was the iron spine of the Wehrmacht. It was the machine that carried the weight of a horrific continent-spanning war on its leaf spring suspension. Even after the fall of the Third Reich, the legacy of the Panzer V did not end. Dozens of these tanks were acquired by Syria in the 1950s, and they were used in combat against Israeli Centurion and Super Sherman tanks during the Water War and the Six-Day War, in the 1960s, a bizarre historical epilogue where a 1930s German design traded fire with Cold War-era armor in the Middle East. History rarely rewards the glamorous prototypes that look good on a drafting table. The true arbiters of military victory are the reliable, the adaptable, and the mass-produced machines that show up to the fight, day after day, in the mud and the blood, until the enemy is broken. The Panzer V was not the best tank of World War II, but it was undeniably the most vital tank in the German arsenal, the true dark horse of armored warfare. Now, we want to hear from you, the viewers who study the harsh realities of military history. Which factor do you believe was most responsible for the ultimate defeat of the German panzer divisions? A. The overwhelming industrial and numerical superiority of the Allied war machine. B. The crippling logistical collapse and catastrophic fuel shortages of the German military. C. Adolf Hitler's disastrous strategic micromanagement and refusal to allow tactical retreats. Drop your answer and your reasoning in the comments below, and make sure you are subscribed so you never miss our next deep dive into the weapons and tactics that shaped our world.